Hopefully everybody had a good break. We'll have another one following this section. So if you didn't get a chance to do everything that you wanted to during your break, don't worry. We'll have another one soon. But when we're talking about assembling the building blocks of a data reliability stack, another way that you might have seen this mentioned is on LinkedIn as the modern data stack, although that definition is always going to be changing. I guess if anybody has any experiences with setting up a modern data stack, please pop it in the chat. Any learnings that you've had, and then also Molly asked where everyone is calling in from today. If you haven't had a chance to do that at the beginning, but we'll start with data stores. That's probably where you'll start with if you were to build a data stack net new, and where you'll see data generated and stored for both analytics and probably like dual purpose in the beginning. And then we'll move on to data warehouses versus data lakes versus data lake houses. Short answer there is that it is going to be primarily workload dependent, although we do see a lot of these capabilities converging. So over time, the meaning or terms of data warehouse versus data lake house, I anticipate will actually fade away. So first things first, choosing a data store started with a database. In many cases, at early stage companies, when first setting up a data stack, it's very likely that any sort of transactions that you're processing, for example, it could be any sort of software product information you're hosting. Sometimes marketing campaign information is also consolidated in these. You'll actually probably start off with using it both for storing transactions as well as running analytics. In many cases, you'll probably have this actually set up at the organization that you're a part of or joining. But in the event that you do want to set up a new type of database, either that's because you all are a brand new company starting to record transactions, or you're picking up another transactional database for a specific workload or migrating, then some considerations you might want to start with are, number one, it's actually going to be workload dependent as well. So there are different types of databases that can handle different data types. A few of them are built differently as well. So for example, Postgres can handle and has some inbuilt functions for parsing JSON, but can also handle like geospatial data types as well. So in the event of, let's say you're somebody like a Instacart who is tracking the progress of where people are at, helping you to make sure that your order is coming on time, then you may want to opt to go to do something like Postgres. But in the event where you are perhaps exploring more varied, different types of semi-structured data, then you might want to go with something like a MongoDB that's NoSQL. And it seems that we're starting to see a sort of renaissance in NoSQL databases as well. Although it still seems that Postgres and MySQL are increasing the most in terms of adoption. On the right-hand side, you'll see some of the considerations that you may want to make for making sure that you're considering data reliability when picking every segment of your stack. And the recurring theme that you'll see here is that you'll want to be able to keep in mind how you'll be handling history tracking and disaster recovery in the event that something happens, like, for example, a database server goes down. Please pop in any questions that you have along the way, either in chat or in Q&A. We're starting to move into data warehouses versus data lakes here. On the left-hand side of the screen, you'll be able to see a sample of different types of data warehouses and different types of solutions and ancillary solutions to data lakes. So you've probably heard of Snowflake. Snowflake is one of the more popular solutions in this area. But like I mentioned a little bit earlier, some of the use cases are converging. So you'll see Snowflake often refer to themselves as a data cloud now, for example. But as a quick background, Snowflake and other data warehouses that are shown here, like BigQuery, especially Redshift, were among the first of their type that were built more for analytics type queries in a way that databases aren't. And what I mean by that, like comparing that to the transactional databases that we saw on the previous screen, was that these new types of data warehouses for analytical focused workloads were built, for example, with features such as column storage rather than row storage, which is important when considering any sort of analytical query that you're making. For purposes of this class, I'm assuming that you all are familiar with some data concepts, but so some of this might be redundant. But imagine you have a table that has, for example, basketball player statistics, and you may want to understand how many points somebody has scored on average. In that case, points is typically going to be stored in a one singular column as a field, probably labeled points, NBA player points. And to figure out the average of any sort of points, you would add up everything within that column and then divide it by the number of values within that column, all focused on that columnar storage rather than row storage like transactional database are optimized for. This is a little bit just more technical background that you probably won't need us to dive into as much depth for. The takeaway for this data warehouses slide is that left-hand side, those images were built for analytics queries, typically will perform better, and are typically even cloud hosted. So you won't need to necessarily figure out how to set up a disaster recovery process. You'll only need to figure out what capabilities they have to better help you vet tools that you're using. And now we are swimming into data lakes. So typically, data lakes will be used for any sort of ML workloads. So over time, we'll actually see probably a lot of these tools and let's say coding frameworks begin to become more and more popular organizations that you work with or will work with in the future. The thing that is makes them more like ML workload friendly is, for example, better support for semi-structured data, better integrations with coding frameworks meant to process data, like Spark is listed here, but there's also Beam or Flink as well. But to bring it to parity with data warehouses, there's the most notable differences. There are different storage and interface formats, some which you can see listed here along the slide as well. And a lot of that was actually created to bring data lakes closer to data warehouses' take on asset compliance, which is basically not duplicating or losing transactions. But the converging use case here means that there's a high chance that your data lake will also be used for analytics if it's not already being done already. Now, getting to the meat of some of this. Before we hop into, while we hop into this, one of the questions was, what are the contributing factors that lead to poor data quality at different stages of the life cycle, which we will address in the exercise that we'll be doing very shortly. So when we're considering building a data platform, I'll walk through the slide going from left to right. From the left-hand side, we'll see data producers. These are represented as cylinders, which typically means that they are representing databases as well. But it's not always going to be a direct database connection. In some cases, you may see these data producers be actually actual databases or something like a business application that has a backend database that you're connecting to through something like an API. But it could also be simply third-party flat files that maybe you're buying from some market research provider. Moving into the left-hand side of the screen, we see the concept of a data platform being abstracted into the use cases that it serves. There's a lot of complexity in setting up a data platform depending on what type of use case you're focused on. So for brevity's sake, it's better to abstract it at this point, just to purely focus on, hey, what is our data platform serving? Is it sort of machine learning applications? Is it composed of data management infrastructure? These are all considerations we need to make while setting up a data platform. But think of it, for purpose of this class, as going into the data store and then porting out, getting manipulated to solve for different use cases. And for data consumers on the right-hand side, we can see this as like, I think these are application window icons, but at the end of the day, it'll also be people in some form. So earlier, a lot of you had mentioned that to make for high data quality or indicators data quality, one of them was that people can use it for the business use case. And at the end of the day, it does come down to that sort of people element of who is actually interpreting this. Is it going directly into a dashboard? Who's reading that dashboard? Is it feeding back directly into a business application? If it is feeding into the application, is that sort of self-hosted? Is it our own personal product? Or is it another application that our stakeholders are using to make decisions on the fly? All of these are considerations while you're building out your data platform. Getting a little bit more tactical. When we're going into the 6-layer data platform, or when we're splitting out a data platform into 6 different layers, these are the general categories of tools that we define the modern data stack or data platform as. So we'll go from top to bottom, starting with data ingestion. So with data ingestion, as you can tell from the name, this is bringing data into the warehouse, lake, or lakehouse for your particular use case. Keep in mind that as we're going through each of these different layers, these could be tools, and there are tools that exist for every set of these stages, but it could be in-house built as well. And that's something that typically teams will start off with is figure out how to in-house build something, with the exception of data storage and data processing. People will configure their databases for their particular use cases for the transactions that they're working with. But it's a lot less likely nowadays that somebody is building a database net new from scratch. And that's probably because data storage is the oldest piece of the stack to begin with. Like I had mentioned, with that evolution of transactional databases and then moving into analytical warehouses. But in essence, the point of a data storage and processing layer is to get data in and store data in a way that you can process so that you can easily move your data from raw to modeled within that data storage level, surface it out to business intelligence tools, directly into applications or into a customer-facing product. When it comes to business intelligence and analytics, we will categorize these tools as, like, let's say, dashboards or reports that stakeholders are referencing day to day or created to answer some ad hoc projects that pop up. I am curious too, same question as Ryan within the attendee chat. Does anyone have any particular favorite tools for any of these layers? Please pop in the question as we go along. I like to get a quick pulse check of what people have used so far and what they like using. Frankly, I just think it's extremely interesting, and I want to stay on top of what people are doing day to day and what kind of context, any sort of context you have. Last 2 layers of this data platform, data observability and discovery sit on top of all of these different segments of these layers to make sure that your data flows as expected and works as expected. And I know I didn't mention that much about data observability yet, but we'll talk about it after a quick short exercise. The exercise will request that you all type in the chat. So if you haven't found the attendee chat, I know for me, this is about my 3rd time using On24, this webinar platform. But on the top right corner, there should be a set of 3 icons that denote the menu where you should be able to add a widget like the attendee chat so that you can participate in this next exercise. So as you can tell, we're hopping into the exercise now. To set the lay of the land for the exercise, what we're going to be doing is we're going to be identifying different areas within the process. Doesn't matter here if it's a process or using a tool, but identifying where your data stack could become unreliable when using a small segment of those 6 layers that I mentioned before. So in this case, walking through the diagram again, left to right, is we'll be starting with data sources. The data sources here could be business applications, could be transactional databases. For purposes of this exercise, it doesn't matter too much. You can actually interpret it however you want. And from there, the data sources will be loaded into the data warehouse, lakehouse, centralized storage, whatever you prefer to call it, in its rawest format, depending on what export options are available in the data sources, like an API or like an ODBC driver. And then the data gets manipulated, transformed into tables fit for business consumption, either, in this case, directly going into the business intelligence tool and dashboards and reports, or just in ad hoc queries by the analysts. Quick, what is it called? Quick pause here for any sort of questions about the scenario so far. And I think I just noticed that for some of you all, the attendee chat's actually not working. So if you want to participate through Q&A, but feed it in as the A part of the Q&A, I'm very, very open to that as well. And so it makes it honestly a little bit more fun for me as well. Cool. So assuming that there are no questions, again, feel free to pop them in whenever you want. But assuming there are no actual questions, then we'll hop into the exercise itself. So the first thing that we'll focus on is from data sources through the data ingestion tool or process into raw tables. What are some data quality issues that you all have experienced or think you would experience? Yes. Yes, yes, yes. I'm seeing some feedback now. Well, any other points of feedback for when ingesting data into the warehouse or lakehouse could turn hairy? All right, all right. So there's a lot of different types of data entry, data quality issues that could come up. So when we're identifying data that become unreliable, yes, these are all great answers. We have some of these answers, and I'll read out from the main chat. Every ingestion point could be susceptible to unreliable data, 100%. Data quality issues are going to be unique to every single ingestion pipeline that you build. Data sources are going to have issues too. People might fat finger in a number into a primarily text column as well. Every single step of the way will have issues. I fully agree with that as well. Inconsistent data types is something that I saw in the chat and have mentioned here as well. Incompatible data formats, 100%. That's a little bit of what we were talking about before with different transactional databases and data warehouses being able to handle different data formats better. I love this. I'm doing it this way because my colleague does it this way too. 100%. Your colleague might have set up an initial ingestion pipeline for something else, some other department, maybe didn't take in as many fields as, let's say now the marketing team needs. That's 100% accurate as well. Yes. Yep. We're jumping a little bit ahead into tools and automation to verify model table when is correct. That is perfect. Data does not update. Yes, this could be any manner. Tool itself fails. Maybe the cluster that you're running your ingestion job on fails. Anything related to that. Maybe there's even a conflict with pulling data out of a transactional database because someone else is trying to read at the same time. Redundancy issues within a data ingestion tool, absolutely correct as well. One other example that I mentioned here was missed data. So if you're using something like a cursor or paging, like an API paging extract, then you may accidentally miss updating your cursor of the page for that particular script. A whole variety of things can happen. Every single answer is correct. And we're probably going to continue finding more things over time as well, especially as new software tools pop up. Even new transactional databases are popping up as well. Whole host of issues exist there. Moving into raw table, this center orange, light orange, peachish kind of color, from raw tables to model tables. I think I already saw one. Some of the tools or automation is needed to verify that moving from raw table to model table is one of them. But what else comes up in any sort of transformations that you've seen? Right. Please continue to keep them coming in as well. One of the things I missed earlier was vendors sending bad data. We've probably all seen this. If it's a CSV, sometimes they add in a duplicate row that maybe shouldn't be there. But then in the process, because you didn't expect that row to be there, it doesn't go through your data formatting process like it should through that script. So it feeds in and breaks the table. We've seen that as well. And in moving from raw table to model tables, there's a variety of things that can happen too. Like schema changes are very, very common. For example, the source business application upstream adds in a custom object downstream as well. And in the case of adding in a custom object, it breaks some sort of reference query that you may have made. Or This could even be another human mistake. Maybe they accidentally recast a column into an incorrect data type or incompatible data type because maybe they assumed that people weren't actually running any sort of math equation on there. Assumptions made about dealing with nulls can affect transformations. That is 100% accurate as well. Where upstream, a null gets introduced somewhere, maybe somebody creates a few rows and it actually breaks, again, let's say like an average function as well. Unplanned system upgrades is an interesting one that I did not list whatsoever. That is pretty important as well. We've seen it break entire warehouse, or seen it break multiple queries downstream when a warehouse goes down for, let's say, some sort of even planned maintenance. And then next up, and the final portion of this exercise before we go through some takeaways and some additional questions that popped up throughout the presentation, was the this last segment, moving from a model table to a BI tool or ad hoc query, what can also break? Schema changes is definitely one of those for ad hoc queries. And you can feel free to use whatever BI tool you have in mind for this example, because a lot of it is very BI. It's going to be partially BI tools dependent too, and how it interacts with the warehouse or lake house that it's plugging into. And to Ryan's point, I've both broken my own pipelines with schema changes as well as broken other people's by deleting tables. Deleting tables is also a human error, human big error in some cases. Luckily, in that case, the business is still doing fine today. So we should have to consider disaster recovery as well as part of the reliability of a data stack. And I think that's a fair, sorry, Ryan, you'll probably have more to add there.